Okay, yeah, so this is the second review for constrained impersonation, October 23rd, 2025. Last one was like in September. So, okay, Jordan, have you looked at this at all yet? Okay. So my thought was I would walk you through the small diffs for the various like surrounding files first, just to kind of set the stage, and then there's like three new files basically that cover the core implementation. Um, so if we get started, the cube feature stuff is pretty straightforward. Brand new feature gate, alpha 135 disabled by default. Nothing unexpected there. Um, these changes are because of the change to audit, which I think is easier to see, not in the proto apparently, in the dot proto, I think, yeah. So there's two new fields added to audit. One is the optional authentication metadata, and then within it, the optional, um, yeah, within it, the impersonation constraint. So in the main audit event, you might optionally have this metadata if impersonation, constrained impersonation is used, and sort of the mechanism for that use is captured there. Nothing too interesting. Here's the go
Is
types.
is verb impersonation constraint is a verb?
It is the verb, right? So it would be impersonate colon the mode you used.
Okay. All
Yeah.
right.
So,
And
nothing.
that is only set when impersonation was used and constrained impersonation was used.
Right. So for legacy impersonation, even when through the new re-implemented logic, we'll purposely set it to empty string and not not forward it. Like the way the logic is written, that struct is not instantiated at
Yep.
all.
Yep. Okay.
And it's a pointer. Um,
Yep.
so it should not show up at all with omit empty and everything. And then conversion is nothing particularly interesting in any of the code gen. Um, it's just the internal type. Deep copies are straightforward. So here's the actual logic for setting it. So when the constraint is passed in, if it's greater, if it's not empty, then we'll put it here.
Populate it. Yep.
Um, and then yeah, this is just the logic for passing the constraint through. This was a trivial change for on the authorization decision because I log it in a place and it is unhelpful to get a 0, 1, or a 2 back. It's much more useful to get a human readable string. So um, we'll come back to the main impersonation changes. I just dropped this one parameter because it wasn't used because I edited that function. Um, where did I? There we go. Uh, I had to break this function into two so I could use it as a helper. Nothing, no behavioral change. Just I just need to pass stuff through it. Um, that was just dropping the context because it was unused. This is just copying the feature. Sorry, this is not a copy. This is the actual feature gate that was used in the other spot. Also, nothing super interesting there. So this is the main default build handler chain function. And so the way this works is if the feature gate is enabled, you get the new handler, and if it's not enabled, you get the old handler. So the new handler fully replaces the old one. So the new handler has to re-implement legacy impersonation. And then we already talked about the feature gate. And right now, the only test in here is an integration test. And like Jan and myself are going to work on adding all the unit tests. And if you have requests there, we can make sure that I record those so we get those covered. The integration test just gets the high level functionality exercise, nothing too crazy. Okay, so any questions there, Jordan, before I go to the main logic?
A random one.
Okay.
Uh, we dropped the filters authorization.go.
This
Yeah. Why do we drop the context?
it just wasn't used. Because I had to break this function into two functions
Uh,
for use. I was like, oh, there's no point. The context is just unused, so I just dropped it altogether because we just weren't using
okay. I okay.
it. Yeah, I'm not really sure why. Um, Also, and as a side, it also takes requests as input, which also has the context. So it's like, what? Um,
Okay, that's fair. Uh,
um, so that's that. So you'll notice that if you look at the file structure now, there is a new folder for impersonation because I could not tolerate keeping it in one file when it was getting insane. I had to at least split it up by some level of structuring. So I just made a folder and moved all the stuff in there. Um, so this is the legacy impersonation code, and you can see the diff is very minor, just changing the package name because the file moved, dropping
Bless
the
you.
context. You what?
Bless you.
What?
Thank you for keeping the diff of the existing stuff
Oh yeah, yeah.
inspectably tiny.
Oh yeah, yeah. I was sad that I had to change it at all. 'Cause I was like, I just don't want to touch it. And the test is obviously just really minor package stuff. Okay, so now we can look at the actual new code, right? So these three files, there's no point in looking at the diff because they're brand new. So I have them open. Okay, so there's no metrics yet, but that is a to do. We will add those. So right now, the only way to observe this feature in use is through the audit logic and the logging, I guess, but that's not super useful. Um, okay, so yeah, so there's three files. There's the main handler file, and the file that contains all the cache semantics, and then the file that contains all the various constrained impersonation, legacy impersonation modes. Um, so yeah, in the main handler, we will process the impersonation headers. They will all get converted into basically the user info that the requester wants to become, right? There was some awkwardness I noticed. Like this if statement's a little weird, but it matches the existing behavior from legacy impersonation. So I was like, yeah, it's fine. And so I think only even applies to HTTP one. Um,
So you could have a header name with no values.
yeah, you could as far as I can tell, you can in HTTP one, and this old function from legacy impersonation would just skip it effectively. It would do nothing with it. And so it wouldn't be
But it sets has user extra to true above that.
right.
Interesting.
And that's exactly what that old code did. So I was like, whatever. Like, at least it's the same.
And if we okay, and so all that does is say we saw a header that looked impersonation related,
Yeah. And so if you
and
didn't person,
we didn't end up with a user.
yeah. And so it was like, eh. Specifically, we didn't get a username.
Yeah.
It,
Okay. Yeah, that's fair. I whatever.
yeah. And also, to be fair though, right? Like the use of get here is a little awkward because that's what we have always done, and that doesn't exactly represent did they set the header or not, because again, they could set it to the empty string and we would say you didn't set it, and that's what legacy impersonation.
Well, like if you gave us a header, well, yeah. I I don't care.
Yeah, it just like, what are you doing if you're setting the empty string as your impersonated user?
So that this bit is shared between the two implementations?
No, it's not. This is
Oh,
so I'll show you build impersonation requests.
okay.
The reason I didn't use it is because it tries to create this weird slice of object references, and I was like, no, I'm just not. You can read this and think about the other one and be like, does it do the same thing? It also tries to do all this type of stuff, which
Yeah. I mean, like, okay. So like this is extracting from headers and building the object references inline.
Hmm.
You pulled the extraction bits out into a separate function, preserving all the existing behavior,
Semantics. Yep.
but turn it into a user default info. And so it has the same like error conditions for the extraction bits. Like if you had some of these headers, but you didn't give me a username, that's an error.
Hmm.
Um,
Yep.
I guess, yeah, it makes it easier to reason about that we didn't touch this at all, even if technically the refactor is just the other bits. But okay,
Yeah, and then also like I moved the deletion logic of the headers in here. So like this is the place you mess with headers. There's no other place you mess with headers. This is the one spot.
yeah, um, that's fine. It means that this code path basically can never change because this is also being used for legacy impersonation when this feature is active.
Mhm.
Um,
I think that's okay because we said the client is not supposed to have to change. Like the client does not need to do something different to get constrained impersonation.
yeah, yeah, that is fine. I'm thinking of the unit tests that I want to make sure that the old behavior, like people using non-constrained impersonation,
Mhm.
don't like get different behavior.
Mhm.
Like the way we extract headers into a user info and then go from there to the old legacy object reference craziness. Um, like I, uh, are we doing this extraction twice?
What
No,
do
no,
you
no.
mean?
Sorry.
Yeah.
Okay. I'm just. So you re-implemented legacy impersonation.
Mhm. The
Okay.
entire thing from scratch. There is almost no code reuse because the thing was unreusable.
Okay. Okay.
Yep.
So we will test it at the like from the outside, like feature enabled, feature disabled, legacy impersonation behaves the same. We'll look at like what authorization calls are getting made
Mhm.
and what user info do I end up with.
Mhm.
Okay.
Yeah, like one of the things is so like we have at least some, we have some existing impersonation tests, right? Not that it's not that great or anything, but it's something.
Yeah.
Um, with I think minor tweaks to them to make them tolerate, the unexpected new checks that will fail, right? Because constrained impersonation goes
Yep.
first. Those should all pass because it should do exactly the same thing.
Right.
Um, and so that, yes,
Did they assert exact shape of resulting user infos? I think some of them did.
some it
Okay.
maybe. They're not the tightest coverage. They're
Sure.
from an older time, an earlier time where we
Yeah.
were.
Okay. All right. Let's keep going.
Yep.
Um,
Okay. And so in this whole thing, right? So after you have the user that they want to be, if it's nil, they didn't impersonate, so we just move on. Um, Otherwise, we basically get the authorization attributes, and the gist is this impersonation tracker thing, which is, outside of the handler logic, is basically saying, can the requester making this request impersonate this user during that request? Right? So can the requester become the wanted user and then do this request? That's what it's trying to figure out. And if all that works out, then it just does the standard replacement and audit logging stuff. So
Um, we should go doc the impersonation headers function like only contains exactly what was requested via headers. Like this user default info doesn't, like, there's no extra stuff injected at this point.
this part is the
Yeah,
one thing.
yeah.
Uh,
Like this returns user info containing only what was explicitly included in the impersonation headers. So we don't have authenticated groups, or we don't have like automatic service account groups or node groups or anything
mhm.
like that,
Yep. Okay.
which
Do that.
is good. We just want to be clear about what we have here.
Yep. Yep. Uh, yep. Can do that. And so then this tracker thing that is like shared in the whole handler. Um, it has the slice of modes that it's going to try, and then it
Mhm.
has a very simplistic cache that remembers um, ordering for, or not really ordering, the successful modes per user. So that way, if you successfully legacy impersonate, we will try that first for you instead of trying it last. That way, over time, the system doesn't behave poorly. I just this whole block is just there, so there's some way to observe this feature in a like what is it doing? Because there's really like these authorization checks are like completely opaque otherwise. Like they're not contained in the audit logs. They happen, but the record of them happening is nowhere. So I was like, all right, the RBAC authorizer at level 5 gives you a bunch of details, so fine. At level 5, we will also give you a bunch of details. Um,
All right. Um, and
uh,
obviously the tracker has to be like totally thread safe.
yeah,
Okay.
yeah. So the caches are thread safe, and the mode is completely static and not changed in any way.
Okay.
Um, so one of the things I did change since the last time you looked at this, the tracker now outside of this ordering cache has no concept of caching. So any caching that happens exists within the modes themselves. It does not exist here. Okay, so from the perspective of this tracker, oh yeah, I guess the only caching is it will create this shared key and pass it through, but it doesn't do anything with it itself. But it has to be the one creating the key because otherwise they can't be shared. Um,
Okay. So
um,
when I'm impersonating on a particular node,
mm,
wanted user is going to be that node's name.
no, because that mode is super freakishly special and requires absolutely insane logic and has by far the longest comments.
No, no, like when I get here, like wanted user is going to have
Oh yeah, yeah. When you get here, yes, it'll have it, and then that
wanted
mode
user
proceeds
is
to just
like
ignore it
node
completely.
foo, and attributes is going to be like service account, foo
Mhm.
daemon set blah with
Yep.
this extra info and pod UID and all. So like this is still at the level where it's the actual attributes and like the actual user, specific user I want. Okay.
Yeah. Yeah. It's very raw at this point. There has been sort of no defaulting or any mutations really. It's just basically the stuff was taken off the wire, and now you're going to try to do something with it.
Okay.
Um, yeah. And so this logic is just basically saying, okay, the whatever mode succeeded for the user last, try that first if they come back.
Hmm.
Otherwise, just try them all, and don't try the same one twice because that's silly. Uh, uh, and this is documented in the mode stuff, but like for example, you can get a nil user, and that just means the mode didn't do anything, and just keep going. Uh,
Uh, so the last successful mode just remembers it's a singular one. Like it's
yes,
okay. And the index cache, is that like least recently used or time expired or evictable or
yeah, it's LRU 1000 entries ish, 1024, but integers. So 1024 integers plus usernames. Um, I figured it was fine that because usernames come from the authenticator, so like your authenticator isn't going to try to break your cache because
Yeah.
it's part of the API server effectively.
Yeah.
Um, but yeah, once you get here, no matter what, either you're gonna get a user or you're gonna get an error. You're not gonna like somehow come out of this function with both nils. Um,
Okay.
um,
Um, Add a comment on the index cache. Like, I don't know how to think about sizing of these things. Like 1,000 seems like a lot until you're running a cluster with like 10 or 20,000 things in it. It's like, okay, maybe that's not a lot. Uh,
so
oh, but but uh,
common.
but, uh, but uh, never mind. It's by username. So
Mhm,
if it's like a daemon set, that's going to be shared across
mhm,
daemon set service account. Okay.
mhm. Yeah, it's very simplistic. It's just the username.
Okay.
Like, sure, if you had one user using different modes, they're just gonna be kind of smacking. Like, what? I don't
Yeah.
even know what you're doing. Just pick one. Pick one approach or the other. Don't do
Okay.
17 different things.
Maybe still add like a let's think about how to size this, or think about like how much memory does this take? If it's the difference between like 1 megabyte and 5 megabytes, like let's take the 5 megabytes of memory and track more. I don't know. It's not a big deal, but
Yeah, so this is the whole thing. What, like, do you want me to maybe leave a comment here on so it's
uh,
LRU?
let's just do ballparks on like how much memory these things are taking, and if we could bump this up by like an order of magnitude, and it would be the difference between like 1 megabyte and 10 megabytes of memory. Let's just take the 10 megabytes. Uh,
Okay.
uh, anyway, just think about like ballpark size we expect, and if these are sizes we're happy with. We don't need
Okay.
to be super fancy about it, but
Okay. Size of this cache, and should we bump the size to
I I don't know. Rather than like just saying like I don't know, 1,000 feels big. Let's sort of think what do we estimate the memory to be? How much memory are we happy with this taking? Five
okay.
megs, 10 megs. I don't know. Um, yeah. All right,
Okay.
let's jump back.
But yeah, so the get logic. So yeah, I think now we can look at some of the cache stuff before we get to the mode stuff. So yeah, the get logic is really simple. Just check by the username, otherwise -1, or get the integer. So very simplistic. So the vast majority of the size is going to come from the name. If we're really worried about the name being too big, I could hash the name to compress it, or give it a fixed size, really. Because again, it doesn't actually matter if you get the wrong value out because you're still going to try all the
We're still
modes.
going to try them all. Yeah, let's hash the name so we can reason very confidently about the memory consumption, and uh, then no matter how long your usernames are and how crazy they are, um, yeah, it'll be constant size basically.
Okay, that's fine. So I'll do
Uh,
that. And so yeah, then we could get it down to like SHA-256, 64 bytes times
yeah,
whatever.
yeah,
Be pretty easy math.
yeah.
Okay.
Just as a nit, return int bool instead of treating a -1 as a thing. If we don't find it, return 0 false. And if we do find it, return whatever it was true. So
Okay, to
it,
change. Okay.
because someone will definitely take that value and be like, haha, index into array -1. Anyway,
I mean, there's a guard for that, but sure.
yeah, whatever. All right.
Okay, that's cool. Yep. So that's fine. I could do that. All right, so now I'm going to talk about this other cache in the abstract before showing the use of this cache. Uh, just bear with me. It's 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 special, I guess. Um, okay, so this cache is basically used in two different ways in the modes, but it's reused. And in particular, the same cache key can be passed to different caches running in different modes, and it's fine because the meaning of the cache key is just dependent on basically this mode that the cache is in, but not like if a mode has a specific thing it needs to do for caching, it just does its own thing. It doesn't reuse the same cache key. And there's only one mode that needs that, which is the associated node one. All the other ones.
So we have the common cache, which has two ways of operating.
Well, there's only this cache. It's
Okay.
just that the mode, the associated node uses it very differently. Basically, it creates its own meaning by not using the cache key that's passed in. It uses a different cache key that it creates.
So, okay. So what the heck? What
Dude,
I'm
you,
trying to understand why we have a Boolean here, which can
Mhm,
be true or false. And
mhm,
you're telling me there's a third thing, which is like another use that has a different key that gets passed in. So we have, when we call get,
mhm,
get is a function of the cache key we pass in
mhm,
and the Boolean true or false
mhm.
configured in the cache.
Yeah.
Do
So
we, okay. Okay, so tell me when we set this true and when we set this false.
yeah, so this is set to true for the outer cache that basically remembers Mo impersonated Jordan to get pods, right? So the whole thing, it's just like the outer thing,
It's
right?
set
But
to true, we skip attributes.
oh, sorry, no, it's set
Set
to
the false.
false. Yeah,
Okay.
this one. When
Okay.
skip attribute is false, yeah, basically this line, right? It's like the mapping in the cache when it's false
Mhm.
is wanted user and attributes. When it's true, it's wanted user and the requester. In particular, the specific request being done is not relevant.
So attributes is all the attributes. So requester plus
Yeah, I mean,
uh,
attributes contains
okay.
requester.
Skip attributes is still paying attention to some of the attributes, but just the user info part of the attributes.
Yeah, that's why it's like in all the parts of the code, I call it the requester. Like the user trying to do the impersonation is called the requester, just everywhere.
Okay.
So yeah. Um, so within each mode, there are mode specific caches. In particular, so there's two of them. One is the outer one that covers like was this exact specific request done by this exact requester impersonating this exact wanted user. If that happened, cool. Here's the resulting user info, and that's great, right? But that isn't going to necessarily have a great hit ratio in the sense of like if I both get pods and get config maps, well, obviously that's not going to help, right? Um, so the secondary cache, which has the skip attributes to true, is the one that remembers was the other impersonation checks, the ones that roughly look the same as legacy impersonation, but now with a slightly different verb, are those still cached, right? Because it's the same check. It's not dependent on the other previous authorization check, right? So it caches at that level. So like the specific example would be, say I can impersonate you, Jordan, to both get pods and get config maps. The first time, that would take two checks, two authorization checks, but the second one would just take one extra one because the um, the impersonate on check would run as a new check because it hasn't been cached, but then the secondary one would say, yeah, it's already done,
Hmm.
right? So that's what the second cache is trying to amortize the cost of, right?
Okay.
But they all use the same cache key, but in different ways, right? So that's why the cache determines how to interpret the cache key being passed in. Like basically which parts of the cache key matter for the cache, right? So the cache itself has like its own behavior. Um, so yeah, so this gets set in the constructor. It's just an expiring cache, just 10-second TTL, hard coded, just copied from token success cache TTL, just like you get a really tiny cache. I don't think we really have to worry about the size of this cache because it's so short-lived. If we wanted to make it larger, then we probably would have to start figuring out a cache size limit.
When does expired stuff get removed?
Uh, every time you set something new.
it sweeps and removes expired stuff.
Yes. It runs GC inline. So basically, at most, you're going to be holding on to like, um, I guess you could hold on to whatever you managed to hold on to for 10 seconds, assuming that no other impersonations happened.
I'm a
But
little surprised that that isn't a bottleneck, but to do for another time.
yeah. By the way, we there's that PR open to fix some of the performance issues with this cache for
Okay.
KMS. I think it's way, way worse for KMS because like the EKS folks were using it with encrypt all. So then it really starts bottlenecking for them.
Literally every write. Although this will be used for read paths as well.
Uh, yes, but the read path only does the read lock. It doesn't do the write lock. So you can have
No, no,
many.
no, no. If I do an impersonation request
Mhm.
for a read,
Oh, like a get.
like a get, yeah,
Yeah.
that will do that will stick stuff into the cache. Um,
Yes.
I I don't think it's blocking for this, but uh, I'm just imagining like a daemon set.
Yeah.
uh, maybe it's actually not that bad because the username is going to be shared. So even if there's 10,000 of them, we're
Yeah,
going to
they'll very
insert
quickly.
into the cache once every 10 seconds or something. Okay. All right. Uh, we
Yeah,
should
they don't insert into the
the,
cache unless
the the
except for the
inline
state.
like the inline GC is like a thing that I suspect will need revisiting at some point, but so I don't want to
Well,
predict.
yeah, so those folks they have a PR open for this. I gave it a pass to fix some of
Okay.
the semantics of this. So I was not comfortable saying it was okay without really closely looking at it and having some more eyes on it because I was like, this is a really small change, but it basically changes the guts of this cache completely.
Mhm. All right. Uh,
Okay.
keep going.
Keeping going. Okay. So then, if we're looking at the actual logic for the cache key itself, um, so it's lazily constructed when you call key, and then it just has two ways of being called. So it's not thread safe, but it doesn't assume it's never going to get called in more than one thread because it's inside the handler, right? So none of the modes run in parallel. You sequentially go through the modes. So
Okay.
there's no
The
parallel
key
mode.
is per filter
Yes.
replication. Okay.
Yeah. So yeah, there's no shared state there. And basically the first time it is run with either of these methods, it will store the result in itself and then, just return it if it's there. Right. So that makes sense.
I see. Okay.
Yeah.
So it's lazily building both.
Mhm. Yeah. And it's okay if only one of them gets used. It's fine, right? Like if the outer cache has a success, then this other part will just never be called, and it's okay. Um, and then to reuse the key building logic, it just calls the same function just with like empty attributes and requester set, just so I don't have to like make a new function for a slightly different way of building a string.
Why are you call what? Why the defer? What?
Oh, the defer is there so that I can set the the result of this into itself without like having to do it afterwards.
Just just say out error equals build key and then set it and then return it. The defer is super weird to read.
Say again. Say do what?
Just save the result of build key into.
Oh, okay. Just don't use a defer.
Don't use a defer. That's okay. I
Okay.
I was like, yeah,
Okay. Okay, fine. I
be
won't.
less fancy.
Dude, don't be fancy. Okay, fine. It's fine. That's not a problem. All right. So then we get to the building key logic, which is kind of insane looking, but it's fine. It just I had this little I made this little helper thingy for a cache key builder, and then we just basically take all the fields and shove it in, and then we hash it. So it's the name of the requester and then the hash of everything else, roughly. That's the cache key. Um, we can kind of
So
see
the
what.
name is verbatim.
Yeah, I mean it's also part of the hash, but the name is there just so that if I somehow manage to get a cache collision, you're only
You can't
colliding with stuff.
collide. You can only collide with other things you did.
Yeah, so it's like you
Yeah.
can possibly screw it up.
Yeah.
Uh, and then yeah, so then there's the cache building logic, and I have some to-dos to explore, like if I should use like a sync pool for this buffer and stuff. I figured I'd benchmark it and see if it actually matters before I start like getting crazy with my optimizations.
Okay.
But yeah, this is just using the CryptoPy builder, but with a little helper on top, so that way I don't have to like do crazy stuff like this myself everywhere, where it is like a Boolean. Um, but yeah, and so it uses a hash at the end. But like for example, in the cache key logic for token authenticator, we use a HMAC with a random key, and I was like, maybe I should do that here, but I decided not to do that right now. Um, yeah, it just makes it even less practical to try to do any funny DOSes against the cache from the outside. Um, but I was like, I'll figure it out if I think I need it.
Okay.
Okay, so that's the caching stuff. So now we get to like the mode stuff where it's gonna get kind of crazy. All right, so do you want to do the worst mode first, which is the associated node, or do you want to do like straightforward one?
Um, let's start with the straightforward one.
Okay, starting with a straightforward one. Scrolling down then. Uh, so we're looking at let's look at legacy impersonation real fast just for fun, right? Because that's also an impersonation mode. So this one is interesting in that it doesn't call this helper function. And the reason it doesn't call that one is this is the one that does that extra authorization check. So instead, it just calls like the underlying logic, which is the original, like I want to impersonate this username, this group, this UID, like that existing logic is contained within this thing.
Mhm.
Um, and so it basically, returns this closure because it still needs to meet this function signature. And it's like, yeah, I'm just going to ignore the attributes and just get the requester out of them. And then that's what I'm going to pass. Right. And so the way that one works in this check logic is I don't know. I was trying really, really hard not to change anything about legacy impersonation, like at all. So for example, the cache is just not enabled at all. Because I was like, I don't know. If people are happy with it as is, I'm just gonna leave it alone. No one's complained directly, at least, so I guess it's fine. Um, Also, it reduces the chance I screw something up for something that used to work. Uh,
Yeah.
so
I if we're using, I mean, the existing stuff is so non-performant. Maybe, yeah, maybe changing the behavior of existing impersonation to make it more efficient, better, is like a distinct thing. So leaving it as is for now. If we want to say like impersonation caching, like that's a new thing, we can gate that separately. We can improve that later if
yeah,
we feel like it. Okay.
yeah. So yeah, so basically there's, four main methods, right? We're going to authorize all the fields that you try to impersonate, right? So again, wanted user is just basically the output of your raw headers, right?
Yep.
And then at the end we do that
All
simple.
of all of the new modes.
Mhm,
The node one only takes the node name, right?
mhm,
The service
mhm,
account only takes the service account name.
mhm,
So the new node and service account modes
mhm,
will only ever authorize username.
mhm.
Okay.
Yeah. Yeah. So they will refuse to even run if you set anything else.
Extra or groups or whatever. Okay.
Yeah, and so they will basically fall through the legacy impersonation because none of the other modes will also match. So it'll just be like, all right, if you want legacy, that's
Yeah.
great. Have fun.
Impersonate user does let you set groups and UID and extra and
Which one? Constrained.
yeah.
So impersonate. Uh, I'll show it here, so it's obvious. So you can set everything except you cannot have your username that looks like a node or a service account.
Sure. Yeah. So if you're doing constrained impersonation of user info, yeah, you can set all the things. So okay.
Yeah, yeah, but you cannot generate a service account with some crazy groups because that's not a thing.
Yep. Yep. Yep.
And so yeah, now after, so you can see this one, takes the actual user and can mutate it. And also here, the actual user gets mutated to have the groups that we expect. And then like the constraint that is reported. So I'll show you that. This one's kind of ugly looking because it takes that. So this has some of the kind of craziness for username, right? So first we just start, we assume just as it's a regular user, but under constrained impersonation, it could potentially be a node level user. So that changes the attributes that you need to check against. Um, and that's, for example, we don't let you mess with groups. So this is an impossible statement to hit, but there's just a guard in case. And then, we'll mutate the actual user you're going to become to have the group you want. Um,
So
but
we're so authorize is both authorizing what they asked for and mutating the result if it passed.
yeah, so this is a separate struct, right, on purpose. So there's never a confusion between what they wanted and what the final result is because we shallow copied it. And
And we hope that there aren't slices in there that they append to or monkey with.
so this does mess with slices, so it makes a copy, right? It's like it literally has a comment.
Okay.
Don't don't do that. Don't be bad. But yes, so you do have to be careful when you're mutating this thing. Um, but yeah, this just steps over the field. So the service account stuff existed beforehand, so we don't need to gate it under constrained impersonation. But yeah, so this, converts the user info to the service accounts one. Sorry, not the user info, the user attributes. And then, um, again, this is an impossible case, but whatever, just check anyway. Uh, and then this is optional because in the legacy impersonation case, you do have the ability to set groups, but, we set it there. Um, Checking authorization is pretty straightforward. Just calling the authorizer, making sure it's allowed. If not, just giving a nice forbidden error. Um, um,
Okay. I okay.
um,
I sort of thought each mode would like take what they asked for,
mhm,
do its authorizations, and then return the resulting user. And the new modes only look at the username or
mhm,
the node and service account modes.
mhm.
Only look at the username, only authorize like the particular things, and then can just return a completely different user. The mutating of the thing is I maybe I'm just getting hung up on that.
Yeah, I mean, at the end of the day, the thing is, like, basically all of them share the same logic with very minor tweaks, right? So, like, this logic is basically the complete logic of legacy impersonation effectively, but it's also required for all of the constrained impersonation modes, right? Because they have to do all these checks themselves in just like the tiny tweakiest different ways. Um, right. So like if we look at, for example, the difference between the service account impersonation mode and the arbitrary node impersonation mode, right? The only difference is this one string and the filter that they match. Everything else is completely shared between them. There's so
Mhm.
that's why the code is structured that way because their logic is exactly the same. This is why I couldn't reuse legacy impersonation because I was like, no, I like need to like contort it in all sorts of ways. So either I could risk causing a massive regression because I managed to screw up some branching condition in the old one, or I can just rewrite it.
So legacy impersonation,
Mhm.
uh,
Right here.
yep, verb is impersonate,
Mhm.
constrained impersonation, false.
Yeah.
And so the difference is the verb that it checks.
Mhm.
So user info is still going to check uh,
It'll check users, groups, UIDs, and user extras, but with the
with the
verb being
verb
impersonate
impersonate
colon
user
user
info.
info.
Yeah.
Yeah.
Okay.
Yeah. So it might make a little bit more sense if we look at the constrained impersonation mode, which has the regular shared logic within it, because all it does is first it tries to see if the filter matches, right? Like, can this mode do the thing you're trying to do, like, to the service account or whatever? Then it checks its cache, the outer cache. And if not, or sorry, if it's not in the cache, then it does the impersonate on authorization. And if that succeeds, then it just calls that other shared function that does all the username, UID, whatever.
Okay.
Yeah.
Um, I would make the same comment about not being clever with defers, and like it's just easier to read top to bottom. If we get the error case return early, if we get all the way to the bottom right before we return out a non-nil out user,
Okay, I do not use. I like these differs.
checking the cache there is fine, but the defer is what's wacky.
Okay, fine. All right. I will remove all the differs. There's like three, and you go like,
Yeah.
that's fine. Um,
Okay.
okay. Yeah, so there's this cache, right? So this is the cache that we can see sets skip attributes to false, right? Because it's like, no, I care about the attributes. I'm the outer cache. I am, I remember the exact request the person made as part of my caching logic. Whereas the inner cache, this one, sets it to true because it's like, no, I only authorize like Mo and Jordan. I don't know anything about pods or whatever. I only look at the starting user and the ending user, and that's what I or the starting user and the requested user. Um,
Okay.
right. So that's why it sets that, and it kind of remembers all those things. Um, Authorized UID is pretty straightforward. There's nothing really special. If it's not set, do nothing. Otherwise, check it. Authorized groups. So there's two branches I had for constrained impersonation that I don't have for legacy, which is one, I don't let you do weird shit like impersonating the empty string group because I was like, I don't know what you're doing. We kind of like it's mostly because this check becomes less and less sensible when you do stuff like that, right? Because the name is supposed to be overwritten with the group name, but if your name is also the empty string, I don't even know what we're checking anymore. So we don't let you do that. But I don't mess with legacy impersonation because theoretically we let you do that in the past. So fine, I guess. Enjoy.
Does constrained impersonation of system masters make sense?
I did I used to have a comment for that and I decided it was fine because if you when you delegate that, you can still control what the actions they can take are. So you can say, yes, you can be system colon masters for this thing, which is basically saying you can do this thing. And if you want them to do that, that's okay, I think.
You can be a super user
Yeah, when
for
doing,
this particular request.
yeah. So I figured that was okay. I didn't feel the need to special case it. I was like, I think that's okay. But if you feel strongly in the other direction, now is the time, Jordan. I can add an if statement saying, "Thou shalt not impersonate that group at all." Uh, that is also a reasonable choice to say that that's not okay.
I mostly don't like system master. We need it for loopback, we need it for break glass, but I
Mhm.
don't really ever want anyone else ever using it. I want them to
Make
make
their own
make
privileged
a
group.
make your own group and actually bind like a role to that group and like make it go to the authorizer and make it answer that. Um, so like the fact that it skips calls to the authorizer, like it short circuits calls to the authorizer, is what's squirrely about it. And we need it for loopback and we need it for break glass, but I don't think anyone should ever be using it otherwise.
Okay, so also to do.
I I would start with that. It's always like we can always relax it and allow like turn things that previously errored into non-errors if we find a really good reason to. Um,
Okay.
yeah.
I don't disagree. I think that's fine. Um, then the other thing is, again, only in constrained impersonation, arbitrarily picked the number three. If you ask for more than two or three or equal, I'm like, how about I check if you can impersonate any group name, and if you can, cool. I'm just gonna stop. I'm like, so if you decide you want to impersonate like 70, I'll just do one check and just call it
Mhm,
good. But again,
mhm.
I only did it in constrained impersonation, so no behavioral change for legacy. It just keeps doing whatever it was doing. And I also did the same thing for extra. If for some reason you're doing something crazy and have a extra with a bunch of junk in it, fine. Also, but is this correct? Does this logic make sense to you? I was reading this for a while and I was like, I think putting these two stars is the equivalent of where we put them before, but with stars. So I think it does the check I want. It's the resources user extras, the sub resources star, and the name of the sub resources star. I think
Um,
means what I think it means.
the loop below is what we were doing before.
Yeah,
The
I mean,
sub resource is the key.
yes. The
Because you in RBAC you can express it as resource slash sub resource.
mhm. So it's user extras slash the whatever
Extra
value
key.
the extra key.
Yes.
So
And
I think
then
this does the right check, right? I think it actually means yes, you have any key and any value for any key. So sure.
what do we consider a large extra?
It's the same thing. If you have three keys or the number of values altogether is also greater than three, I'm open to any arbitrary number that you think is large.
Um, If you were granted individual things, it would be three. The minimum would be 3 checks. If you were not granted wildcard, then the wildcard will fail,
Hmm.
um, increasing the cost by a third in the minimum case when you weren't granted wildcard seems not great. I would
Okay.
probably take it down to like 4 or 5, like 20, 25, 20 to 25%. Like
Okay.
in the success case, we would do 4 or 5, and in the failure case, we're going to increase that by 20%, 25%. Like that feels more reasonable than like a third. I don't know.
Okay. Yeah, like I said, I was just like, I don't know. So
Yeah,
five.
4, 5, 4, 5. I don't know. No,
I'll do four.
sure, great.
It's in the
Okay,
middle. You said five. I said three. We will make
great.
some.
Okay,
Um, so that's that. This is nothing. This is, the impersonate on logic wrapping for attributes. Just make the verb, spread out with the prefixing. I had to copy this function because I'm not allowed to import it. So I was like, fine, whatever. It's just, it's just, it's just a reference. The,
you
this is the
couldn't import it, but you could what?
No, so there is a function called validate node name with a capital V in this here, but I'm not allowed to import it because it's in the KK repo, not the KAPI server repo. So I
Oh,
just redefined
oh,
the
yeah,
oh
okay.
yes. And I was like, fine, whatever. Like, but at
And
least this
that's what it calls under the covers.
yes.
Yeah, okay, whatever. I don't care.
Yeah, I just was like, I liked the name because it was clear what it was doing, and then I
Yeah.
lost the name, so I had to recreate my name. Fine, whatever. But so we can see the logic here for how these things match up. So all of the constrained impersonation ones basically check this function, right? To say that only username is set on that wanted user, right? So
Mm-hmm.
they check that extra is empty, groups is empty, and UID is empty, so
Mm-hmm.
that you can only have username. And we're guaranteed to have username because the outer logic for request header processing won't let anything else happen. And then like for the node cases, for matching the node, for associated node, it is checking the node key on the service account against the exact node name that's being impersonated. Um, so is node name will strip the prefix off, validate it, and then return the validated chunk, which, if I remember correctly, is guaranteed to be non-empty as well. So it can't literally be the empty string either.
Uh, okay, I don't remember, but okay.
I believe you can't, like, a DNS subdomain can't be the empty string. That's what,
Yes.
right? So all that's there. And is service account is just using that same splitting function that we use everywhere else. So then I think we had the higher level picture of stuff. Um, yeah, so like if we think through this one, right? So it's gonna say, did you only try to impersonate a username, and is that username a service account? If so, then I'll try to run my logic, right? And so when it runs, it'll do the outer check for impersonate on for the particular request you're doing, and then it will do the internal check for the specific name for the service account, right? And that's a namespace scope check because service accounts are namespaced. Whereas like the user info one is cluster wide check, right? Because users are not namespace scoped. And that logic is, just shared between legacy impersonation and constrained impersonation. The only semantic difference is in some of the legacy impersonation, the old checks are so old that they use the old API group, the empty string. So that part gets fixed in constrained impersonation, and obviously the verb is different.
Okay, so the mapping of the username to the attributes we authorize on. Like if this is a service account username,
Mm-hmm.
we're going to authorize like a core v1 service account attributes. I mean,
Yeah, so
that.
the attributes are in this one, right? So for service account, we take our username attributes, which are in the group that's configured for the particular mode. So this is empty, the core v1 group for legacy, and the authentication group for constrained, because used we used the wrong one in the beginning because it didn't exist. Like I don't think API groups existed in 1.3 when this was written.
Okay.
Um, but the resource starts off as users, but then instead of being users, it's like, oh, okay, it's a service account. So the resource is actually service accounts, and the namespace and name for the attribute request is the service accounts' namespace and name. And that's what we check the authorization against.
And so node.
Node is the same kind of thing, but it's, it remains cluster wide because it doesn't have a namespace concept.
Okay. Some of this, like, is it even possible to hit line 345?
No, that's why there's a comment that says.
Oh, I can't see. It's like light gray on dark gray. Okay.
It's just there as like if I somehow manage to get here, but no, you can't get here. And for example, this one, you can get here in legacy impersonation, but you cannot get here in constrained impersonation.
Mm-hmm.
But it's again, it's only on constrained impersonation we check because otherwise it would be backwards incompatible. So don't do that. Okay, so that covers, I think, an example of like how things work when everything is easy. Now we can discuss the absolute insanity that is the associated node case. And as you can see, it is more comment than code because it doesn't take much code to do it. It just takes a lot of comments to try to describe what is happening. Uh, you want to take a second to read the comments?
So what the authorizer that gets passed in is the one we're going to use to check stuff.
Mm-hmm.
Wrapped authorizer. Do the others construct a wrapped authorizer?
No, everyone else just uses the authorizer.
Okay. And the only reason we wrap it is so our error message is.
No, we wrap it so we can change the attributes we're passing in.
Okay. I see. And that's what I was saying about, like, if we've decided that associated node like we want to authorize that without respect to the node name, like we're ensuring the node name matched your node extra. Like we already made sure that matched, and what we're authorizing is your user, regardless of what node it's running on,
Hmm.
can impersonate the node it's running
Hmm.
on. That's what this mode is for. So
Right.
we're going to make sure that that matches before we get into the authorization checks.
Yeah.
And then we're going to drop out the node name and drop out your like all user extra. I can't remember what we did.
So the way I did it is this. I just I remember the keys, but I drop all the values.
So our attributes wrapper returns our user wrapper.
Hmm.
Yeah.
Yeah. So the authorizer can see that it is node bound. It can see if it's not pod bound or whatever. Like it can see what information is being redacted from it.
Hmm.
If it and so for example, you could still have an authorizer that said, I refuse to do it because you're not pod bound. I expected you to not only be bound to a node, I also expected you to be on a pod or whatever, if they cared. Um,
Why are we checking the verb inside here?
uh, on this part,
Yeah.
because the reason we're checking is because we pass it to the authorizer, right? So when that nodes check happens, so like, hey, are you allowed to impersonate this node object, that basically the username level check, it will try to pass in the name, right? And because I don't mess with the wanted user or the attributes that I pass into the mode at all, because I don't want the filter to get confused.
Right. But on line 75, we're deciding whether to wrap the attributes we pass to the authorizer.
Hmm.
Don't we only want to wrap it for the
So we wrap it for the authorizer and we wrap it for the cache key. We don't wrap it anywhere else, right? Because we want the authorization checks to have the exact same semantics as our cache key semantics. That's what we're trying to enforce, right? So that's why they're wrapped together. Um, so this part makes sure that when authorization checks happen for the associated node part, that the name they're checking against is star, because our cache key is going to cache it at star,
Mhm.
right? Um, so
But we want to wrap it for user stuff because we always truncate the user extra.
right, we're
Okay.
yeah, in the cache key it's always truncated, and in the authorization check it's always truncated. Um, but basically in the cache key the star is like kind of here, whereas the star for the authorization check is over here. Kind of It's kind of crazy. I mean, it does result in the right authorization checks happening. Uh, and then this part is really bananas, which is that we like partially ignore the result we get. Uh, because we just want to know if it succeeded or not. Because if it succeeded, then we know that this is the username they want. So we just wrap the success again. The only thing good about this mode is it is fully encapsulated in itself. It does not create bananas of complexity in the other places. Uh, but I do think it does what we want. So you can have service account A running on both node 1 and 2, and they will both result in the same cache key for their requests, but then get a different value out, which is their node, right? Like this is the difference in the value, right? This part right here, this wrapper, right? It basically ignores the output from the cache because the cache is just storing some node entry. It doesn't really matter. It just is like an okay, yes or no, basically at that point.
So this mode only is possible when only the username is set and the requester is associated with node, which checks the format of the username
Mhm.
and makes sure it matches our user extra. So at this point, wanted user must only contain
It's a system colon node colon node name, exactly as the service account. And the associated node authorization check is either already passed or passed within the last 10 seconds because it's cached.
and so what you have highlighted now on 102 um,
Mhm.
implements get name, get groups.
It just wraps just the name because we know the groups is correct. So it just lets it pass. Right? Because we know that the only thing that the user asserted was the name. Everything else has to come from the other logic. So it just says, okay, fine. The name is the part that has to change. Everything else should be correct. We know that the nodes have a fixed mapping, so that's fine. It'll percolate up here. Um, but yeah, I believe this would be performant at sort of arbitrary scale.
All right. So the wanted user comes in.
Mhm.
We're going to override just the okay. We're basically gonna divide it into two. One is the one we're gonna use as our cache key.
Mhm.
Then we pass it verbatim down into the constrained impersonation mode. Then we take what came back is the key. Does the wanted user from the key get stored in the cache?
It does, but it's meaningless, really. I could just not set it, and that would also be kind of fine. Because again, right, this cache is specific to this mode, right? So it's not shared anywhere else, right? And all it's remembering is was that service account allowed to do associated node stuff, right?
Right. We have a wanted user in two places being passed into mode. We have it inside the cache key, and we're passing it in directly. Remind
Yeah.
me how.
Yeah. And so that, but from the perspective of mode, right, it does not look at the inside of this cache key, right? It just tries to use it to do cache lookups,
Hmm.
right? Um, so, but the reason, this wanted user is just passed in, right, is so that, like, for example, this filter doesn't need to know anything special, and none of the other logic in the later layers needs to know, right? Because they still need to be able to do, like, is this a node or not, right? So, for example, this is not a valid node name, so it would get mad and say, you're not a node. I'm not going to match you, right? Um, right. So that's why I didn't mess with the actual wanted user. So that way, all of the other semantic checks that like impersonation is trying to do still make sense because they're still using valid values unmessed with by our shenanigans, right? The things that we care about is the cache key going to remember it in the way I want? And is the authorization checks going to match the semantics of that cache key? So that way the authorizer does not unexpectedly grant access that it didn't realize it was granting.
Okay. So look. So on the way in, we're taking the wanted user, and for particular uses, cache key and authorization, we're overriding the username to this system node star.
Uh, this system node star is only just part of the cache key, right? But it's just a static value, so it could just be
I
anything.
I know, but like logically, like the wanted user normally would be passed verbatim in and used to calculate the cache key and passed verbatim to the authorizer. But in this case,
Right.
we're overriding
Hmm.
the username to a fixed value
Hmm.
for both of those cases.
Yeah.
Okay.
Yeah.
And then we take the user that came out,
Hmm.
which if this is the first, like if this is the first one,
Hmm.
um,
Then it would
I'm
be.
trying to figure out what gets stored in the cache. If I've got three nodes, node A, B, C,
Uh-huh.
and I try to impersonate node A, and that's the first one that shows up when my caches are
Yeah.
empty.
So it'll be stored as Node A. It'll be the
Okay,
first one.
what will be in the cache is node A, and when
Right.
I try to impersonate node B or node C, it's going to look up the cache key and be like, oh yeah, you can totally do it. Here you are, node A.
Right.
Okay, all right. That's what I was trying to figure out. Like,
Yeah. And that
um,
and that's why we have to wrap the result here to say, yes, I know you were successful. Everything is great, but because I have coerced the cache key to be the same across nodes, I have to sort of undo that
yeah,
coercion now because that's not what, like, obviously you're not trying to impersonate that node. Now you're trying to impersonate the node you're on.
yeah. What we're doing, I think, is correct. Uh,
And insane.
it
But
would. I'm trying to think how to. I think like variable names, and if the first thing we do in this function is like pull out the username of wanted user as like actual node username, like we save that in a variable. Like this is the real node name.
Mhm.
Um, and then when we get back impersonated user, like name that variable in a way that makes it clear. Like this is the impersonated node
Mhm.
with like not invalid, but
Okay.
because what we get back in impersonated user has some node name, but maybe not the one we asked for if it came out of the cache.
Right.
So um,
So something like, um,
impersonated node.
is it still correct to call it impersonated node if it's nil, like because the check failed? Is that, do you still feel like that's understandable? I'm trying to think.
If it's nil, then you don't have an impersonated node. Like, I don't
Okay.
know.
Okay, so that's
Like
fine.
impersonated node with maybe incorrect username. Like
Mhm.
that's the rub. Like um
I mean, yes, I mean I could literally call it that. I'm trying to think if that's actually, yeah.
uh,
So like I think you were saying something like wanted node name. Is that, does that make it a little bit better? And if it's desirable, I can also do the same thing in the filter so that we're using this sort of the same kind of verbiage. Yeah, something like that.
do we the fact that system node star is in the cache key, like it can um we can't mess with wanted user because that has to pass down into requester associated with node.
That's it. That I was trying not to change it at all because then it's like, oh, now I have to somehow handle it everywhere.
I know.
Um,
Associated node impersonation attributes changes the user info only.
it does both things, right? It changes the user info to do the truncation by wrapping it, and then it also does the conditional on like, hey, if the check that I if the rest of my attributes are behaving in a certain way, then I must be in a particular mode, right? Because these attributes are used for two authorization checks, right? But only one of them we want to mess the name of, which is the one, basically the impersonate dash on check we don't want to mess with the name of, but we do want to mess with this part of.
Yeah, but rather than baking that into the attributes, we could decide whether or not to wrap them based on looking at the verb of the attributes we were given.
Oh,
Like that's in the in the authorizer. Like
true.
up there. Like if the attributes we were given were verb, impersonate,
Mhm.
whatever, then we could wrap. And otherwise, like everything else,
Well, we still have to do this wrapping.
but we still have to do the wrapping for the user.
That's why I was just like, I'm gonna end up wrapping it no matter what. So
Yeah, yeah.
yeah, that's why I kind of ended up doing it that way.
can't wrap early because we need the real node name and we need the real user extra to figure out if we're really associated with the thing.
Mm-hmm.
So the key we're passing to what we're passing to the cache key is basically wanted user with the name overridden to a static value. And what we return is basically impersonated node with maybe incorrect username with the username overridden. Like both of those are taking some base user info
Mm-hmm.
and overriding the username. In the cache key case, we're overriding it to a fixed value, like a static value. And in the result, we're overriding it to their originally requested value.
Right.
Um, I'm trying to decide if it makes it easier to understand to have a override username thing where you pass in the base and you pass in the override, and we use the same thing for the cache key and for the result. Like when we're so instead of wanted in the cache key on line 95,
Mm-hmm.
we have wanted user is override username with a delegate of wanted user and an override of system node colon or system node star. So we're going to say we're going to use the wanted user they passed in as the cache key like we normally would, but we're going to stomp the username to a static value. Now we know that the wanted user only has the username set, but just in terms of like normally we'd pass wanted user verbatim in as the cache key, but in this case we're going to stomp just the name to a static value.
Mm-hmm.
And then we're going to get run our impersonation, whatever, run all the checks. And then when we return override username with the delegate being what we got back and the stomped username being their originally requested value.
Well, let me think through this. Wait, so what are you saying we're gonna mess with this one though?
No. I'm can I let me check
Is there like a request control button?
I was just trying to figure that out. I can just why can't I find pull requests 134803? Like I think what you have is correct. I'm just trying to figure out how to make it less mind bending.
Yes, it is. Yes, it is. Yeah, the only thing good about it is that it's kind of self-contained, so you can just be like, all right, when you're not looking at this part, you don't have to worry that cache key is doing weird stuff or the authorizer is not doing what you think it does.
Let me what file is that?
It is mode.go. I can stop sharing if you want to share.
Yeah. I'm not a host. Dang it.
Oh, I think I can make you a host. There you go. Now you can.
So you had this bit.
Mhm.
Something like that. And then we use it
I see. I see.
here.
Oh, I mean, so technically, I already have a struct that does that.
Okay. Yeah.
I could just reuse that one, right? That one.
Yeah.
I could just rename it as so. Okay, yeah. So if you just want to call it override name, and then yeah,
Oh, that expects. Dang it.
yeah, it has to be
An interface, but
yeah,
maybe that doesn't matter. I don't know.
yeah, it has to be a
Do we depend on that all the way down? Probably so.
yeah. I think so.
Dang it.
Yep.
At this point, it uses the.
Yeah, the
I
the reason wanted user is not the reason that's it's on purpose that it's the struct because it comes from the headers. So I wanted to be like, no, it's not like some magical thing. It's literally the representation of the headers.
Yeah.
Uh, yeah, so that one you can't wrap. You would have to replace it with.
Yeah. Maybe this isn't actually easier to understand. um,
Yeah, like to me, like the only thing that will make this somewhat easier to understand is like looking at the unit test that will be written for it, so you can just see, okay, for this input, I did these checks and this is what I cached, but this is the output, right? Like if you can just see all of those different pieces, that's way more clear than like trying to actually read the code and like make sense for it. Um,
um, and we can't mess with this because that came from the cache.
mhm. Or it could come from the cache. That's
Well, whenever we get it back, it's definitely in the cache now.
oh yeah. That's true. You're right. Yeah.
Yay!
Make those Java users jealous with our names. It's neat that it layers in this way. Uh,
So we're using the same wrapping
mhm,
in our cache key
mhm.
and in our authorization check.
Mhm.
But we're not wrapping here.
Right.
So this is the authorizer. So last mile, what we actually authorized,
Mhm.
what we actually cached with.
Mhm. Yeah. Yeah,
Okay.
it's also awkward to think about because like the authorization checks, there's going to be the impersonate dash on check, and then there's going to be the impersonate colon associated node check. Um,
Um, Remind me why.
I did it that way because um, I didn't like the idea of just flat out just returning nil for the extra. And this didn't feel great to me, or even just returning a fixed value didn't feel great to me. Um, I felt better about somehow letting the authorizer know here's the set of things that I am telling you that I have redacted away from you. Um, make sure you're okay with that.
Yeah. I I yeah.
And also, if you had a special service account token that was just bound to the node that somehow you provisioned versus one that was for a pod, I decided it was fine that those did not result in the same cache key because I was like, I don't like the mechanism for getting those tokens is very different.
Hmm.
Like one is coming, it's probably the node itself doing it versus like some privileged external process provisioning it. So I felt that was okay.
Um, yeah. Does this isn't sorted, is it?
It is.
Sorted?
Mhm.
Okay.
The it's unsorted list that gives you the unsorted list back instead of
Okay. Um, do you have tests that inspect the cache and look at like that's probably what I would try to do for this. Like
yeah. So no, the
build
answer is no. There's no tests for
yeah.
that specific, but there yes, that's what that needs to be tested is that given this starting state, what authorization checks did you make? What did you put in the cache? What came out, et cetera. Like, and the starting state could contain an
And
empty
what
cache, a cache.
authorization, yeah.
Yeah.
So for this one in particular, we should definitely synthesize like I'll see requests by these variants of a service account
Mhm,
to impersonate these variants of a node,
mhm,
uh, and I should expect them to succeed with these authorization calls and this to be in the cache, and for me to get this back. And like once I have an associated node for node A in the cache, a service account from a different node asking to impersonate node A should fail, even though node A is definitely in the cache.
Sorry, say that
The
one.
value is in the cache, but the cache key will.
Can you, no, sorry, say the thing that should fail again. I think I missed it.
So service account A on node A
Mhm,
impersonates node A
mhm.
uh, success cache contains node A.
Mhm.
Service account B on node B impersonates node B. Success cache still only contains node A.
Oh, okay, yeah, okay, yeah.
Yeah, like the key is going to be the star one, and the value is going to be a user info.
So wait, but it
What?
still needs to be service account A, right? On both.
Um,
Like I think you have a typo in the
I don't
beginning.
know. A on A impersonating A should succeed. Oh, I see. I see what you mean.
Yeah, like that.
Yeah, yeah,
Yeah, it was really. I was like, whoa. What?
yeah. Sorry.
Okay, service account A on node A.
Whatever. I'll.
Yeah. So the same service account across two different nodes
Yep.
um,
Yep.
results in the first one being stored.
Yep.
Yeah. But then the second one is the return value is B.
And then if I try to impersonate A, it should fail.
Yeah. So the thing with that one, right, is um wait, service count. Yeah, yeah. So remember though, this one won't even match the filter.
Sure.
Yeah.
But like, yeah, I agree.
Yeah, yeah.
Like,
So that's fine. Yeah, like so we should test it, but I'm mostly pointing out that it doesn't even get to the point of asking anything about cache stuff. It just fails the filter and falls through. Um, and the nice thing is because the caches are inside the mode, they're not shared across the modes at all.
yeah,
You can't accidentally pollute anything. That was part of the reason I moved them into the mode because then I didn't have to worry about like agreement on the meaning of a key across modes because I was like, no, 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 no. Each mode decides what the key means for itself.
yeah,
Um, but yes, so yeah, so I agree with you that that would result in a failure. In this case, it would for yeah, it wouldn't match the associated node. It would keep going to the other checks and just
yeah.
fail in some other way.
If we can introspect the cache a little bit, and you said that for the cache key, we're putting the username first verbatim.
Uh, of the requester, so it'd be system colon service account colon namespace name.
Oh, but that this ends up getting hashed into
Oh
the.
yeah,
Okay.
it's just a pile of goop at the
Okay.
end. Just
But we can see the value in the cache. Like the
yes, the
value is the
value will be
user info.
the final user. So
Yeah.
system colon node A with the groups and no UID and no extra.
Yeah. Okay. So we can tell, yep, there was only one entry in the cache.
Mm.
Do the second request, it'll succeed. There'll still only be one entry in the cache. It'll still be A, but our result should be this thing.
Mhm.
And then asking for that on node A should fail, even though A is in the cache for us. Okay.
Yeah, might have to restructure the code a little bit to make it. I like. I'm trying to think. Um, do you want most of the test to come from the absolute outside?
Um, I'm okay with them being at the mode level. Like it can be a unit test in the package. Like just make sure.
Unit test in the package, but like when you say at the mode level, exactly what do you mean?
Like uh, like a unit test that constructs this thing.
Okay.
exactly the way we're going to construct it for reals,
Mm-hmm.
and gets this, and then like unit tests this. Like it's gonna
Okay.
call this. So I think
Yeah.
you'll actually need a type that you
Yeah, I
can
think we'll have to
like
make it a
poke at
type.
the internal members of.
Okay, that's fine.
Yeah,
We can do that.
yeah. So make it return a type that you can get access to the private internal guts of to introspect the caches in a unit test, but unexported, obviously, and
Yeah.
yeah.
Yeah, I'll have to figure out how to make that work with legacy impersonation and stuff, but it's fine. That shouldn't be too bad.
Okay.
I think it does what you asked for, Jordan.
It does. Thank you.
Okay. All
All right.
right. All right. You said it was going to be an hour, Jordan. I think you were really optimistic.
Yeah, yeah.
Okay.
How do I stop sharing my screen? Am I still sharing my screen?
No, you're not sharing your screen.
Oh, I already stopped. Great. All right.
Okay.
See you.
All right. Thanks, sir.